2019. My name is Hisham Al-Askari. I have the pleasure to moderate this session, the so-called plenary session number 3, Research and Innovation Facing Water Scarcity. It's quite a privilege and honor to be here with all of you today and looking forward to have a vibrant and interacting session. We have a panel full of distinguished speakers, and I'm looking forward to hear every one of them and looking forward to have a discussion and take your questions when the time comes. If I can have my presentation, please, appear here. Here we go. As I mentioned, we have an extensive list of speakers for this session. Over the past couple of days, we have been hearing about water scarcity. We are here in this kind of water week like to talk about water scarcity issues and what the world is facing in the coming few years. We heard in the first session of the first day talk about the SDGs and how we are not doing a very good job in achieving some of these SDGs. We have heard yesterday some of the issues which are happening between countries, talk about transboundaries and the sharing of resources. And everybody, in both sessions, and I'm sure that you're going to hear more of that tomorrow, talk about global climate change and the issue of water scarcity. This is a satellite image from what's so-called the GRACE experiment, which is a gravitational anomaly-driven experiment. It's not based on electromagnetic spectrum, which is the common kind of knowledge that we are aware of, but this is based on the gravitational anomaly. And gravity depends on mass. So basically, when you have a mass of water in the underground, this is when you can see, based on how the satellite works, like an advancement or a disadvancement, which is a representation of a recharge or a discharge process. And as you can see here, this is an image taken from satellites by NASA saying that this is the worst drought in the Eastern Mediterranean for the past 900 years. So over the past 900 years, this is the worst ever. And you can see, those very, very dark spots on Cairo, on Egypt, which are a representation of the lack of underground water resources. All of us are aware that 97%, if not a little bit more than that, is coming from outside the country. Some projections based on research which is published this year about the future of water scarcity and stress. You can see the projection of Africa 2025. A lot of countries are already under stress and some are scarce. And you can see 2050, some of the countries right now which are having enough precipitation are going to also be looking into water shortage over the future, and this is based on 10% decrease in the available water resources based on the potential available water storage index, which is also driven by underground gravitational anomalies. So research and innovation is needed in order to address issues of that sort, either on thinking critically about using the current technologies to make more efficient usage of the current or the existing resources, or in order to look into future possibilities, other technologies, other options, how intersection between data sciences and Earth observations can play a major role for us to understand or to have better understanding of the current existing phenomena or anomalies. We would like to see how physical phenomena, different physical phenomena can be driving the whole system. So in this session, we are going to be hearing a lot about farming techniques, about different irrigation systems. We are going to be hearing about the telemetry. We are going to be hearing about the usage of Earth observations, as well as talking about the intersection between data sciences and Earth observations in order to address global phenomena like El Nino. Our esteemed list of speakers consists of Dr. Elga Salvador. She's a lecturer and water accountant expert at Delft. I cannot see, I'm not getting that old. Yeah, IHE. IHE for Water Education, the Netherlands. We have Dr. Giovanni Del Santi from GRC Institute, Italy. And Daniel House, he's the project manager of Irrigation Training and Research Center, California Polytechnic State University. Here we go. And Dr. Zahran, the Ministry of Higher Education and Scientific Research, and he's the president of the National Authority of Remote Sensing and Space Sciences. Dr. Ayman El Sayed, the head of Monitoring, Communication, Information, and Assets Sector at the Ministry of Water Resources and Irrigation. And Dr. Thomas Piota, he's the Vice President of Research at Chapman University, a well-known hydrologist and climatologist, and I have the honor to serve as your moderator for that session, Hisham Al-Askari, Professor of Earth System Science and Remote Sensing at Chapman University. Without further ado, I'm going to get going with the first speaker. Howard is going to be joining us today. Daniel is going to be joining us today over Skype. I gave like a brief intro about Daniel already, and I'm going to just leave like these bullet points up for a few seconds until he is getting ready. Daniel, can you hear me?
I can hear you. I can. Can you hear me?
Daniel?
Yes. Hello?
Daniel?
Hello, can you hear me? Yeah, I can.
I can see you talking. Skype, please.
Can you hear me?
Yes, we can. Okay. So Daniel is going to be talking about modernization of on-farm irrigation systems in the Western U.S. Irrigation Training and Research Center, Bioresource Agriculture Engineering Department from California Polytechnic State University, San Luis Obispo. Daniel, the floor is yours.
Thank you, Hisham. My name is Dan House, and I'm a professor at the Irrigation Training and Research Center at Cal Poly here, and we do at the Irrigation Training and Research Center work throughout the Western U.S. and internationally. Can you hear me okay?
Yes, you can go back to the first slide again.
Okay. If there's, so I'm going to talk about modernization of on-farm irrigation systems. I hope you're having a nice morning. There's a little feedback on my end, so it sounds like I'm breaking up, but I'm just going to go ahead and push through. The talk today, I'm going to talk about on-farm modernization, providing some U.S. examples. That's what I was asked to talk about. I think it's probably as important, if not more important, to talk about the challenges and constraints to on-farm modernization, and specifically international challenges, but we felt them in the U.S. as well. And then talking a lot about the details of the modernization. So, defining on-farm modernization. It's similar to irrigation project modernization. We get set of technical and managerial upgrades at the field level to improve water management and crop production. It's not a single technology or operational change. It will depend on the farmer goals, the crop being grown, topography, soils, and many other factors. In all cases, as I will highlight, the full on-farm modernization will require water supply provided at a high degree of flexibility. From an irrigation project, that would include good service from that irrigation project, and I'll talk about that here in a little bit. So where to start with the U.S.? I'm going to talk about California. That's where I'm from, but I work all over the western United States, from Montana down to New Mexico, and then throughout California and all the states in between. The California, we have Mediterranean climate. It's we get frost the winter time in the Central Valley, but it's not really cold like it is in the Midwest. We have a lot of orchards, vineyards, vegetable crops, dairies, and thus dairy crops, hay, corn, and other crops to feed the dairy cattle. With the orchards and vineyards and vegetables, we see a lot of modernization towards drip and microspray irrigation. Dairies, because of the flat ground in our Central Valley, and laser leveling that's occurred. We have surface irrigation is still the majority of the acreage in California is surface irrigated, and that can also be modernized. Other Western states, we see a lot of center pivots, and in some areas, especially to the north, consider wheel line side road sprinklers modernized. Some drip, especially up in Washington, where we have a lot of apples and vegetable crops and orchards and vineyards. Some examples here, we have subsurface drip on alfalfa. This is somewhat new. Really over the last 5 or 6 years, it started to take off. Alfalfa is generally not considered a high value crop, so it's been a little late to the game. Also, there's some other technical issues, but we've seen some good results with subsurface drip on alfalfa in the longevity of the alfalfa stand as well as the yield. Here you can see some injection of drip tape into an alfalfa field, or will be an alfalfa field, and a filter station that would be typical for subsurface drip irrigation. Surface drip tape, another option. These are vegetable crops, higher value crops along our California coastal areas. With the very mild climates, they will get 3 harvests a year. And with the surface drip tapes, they put new system out 3 times a year on these fields. This image here, you can see the tractor that's laying out the drip tape. Here's the drip tape in the rows, and it's supplied, and they've germinated with sprinklers, and now they're laying out the drip tape to finish the lettuce crop they have growing. And this is what you can see when it gets a little older. Micro sprayers and dual line drip on orchard is very common, especially in the Central Valley. California is the largest producer of almonds and pistachios in the U.S., and so we have a lot of acreage, a lot of drip and micro spray on those acres. The almonds really like a large wetted area, which you can achieve with the micro sprayers you see here. Again, filtration is very important. This also shows a variable frequency drive for the pump, lots of other details. There's a reservoir that I'm sitting on taking this picture. As we move outside of California, we see a lot of center pivots, considered on-farm modernization, obviously. This is a large irrigation project in northern New Mexico, all center pivots, all pressurized from the irrigation project, all the water's pressurized from the irrigation project. A couple other center pivots here. A lot of forages grown, but also carrots and some beans and corn. Linear moves have never really taken off anywhere in the U.S. They're hard to manage, hard to get water to consistently. Lots of details with linear moves, but a few people like them, so they stay. I see them once in a while. Wheel lines and side rolls in California would not be considered a modernized irrigation system, but in Montana and Idaho, in our northern states, where we have a lot of alfalfa, undulating terrain, these are much better than surface irrigation in those areas. So we still encourage these in certain areas, depending again on the topography of the crop. And then surface irrigation. If you can have very level ground, these are all laser leveled, GPS level now, short runs. They're using gated pipe here to split the field. They have a short run, higher distribution uniformity. Need to have tailwater to get that good distribution uniformity, so you have to capture the water and then recirculate it on the farm to achieve a high efficiency on the farm with surface irrigation. And so I could spend a lot of time, hours and hours, days and days talking about systems, then irrigation scheduling, and weather stations and remote sensing. I do a lot of remote sensing, drones and aerial imagery. I don't believe in drones, but a remote control system components, frequency drives on stations. I work with all of these things, but at the end of the day, we really need to focus in on water supply. So the remainder of my talk, I want to talk about constraints on modernization. So the biggest constraint is irrigation supply flexibility, so getting water to the farm with a high degree of flexibility. Without a high degree of water delivery service, especially flexibility, which means flexibility in rate, duration, and frequency of deliveries, there's no reason to discuss on-farm irrigation modernization. In general, international irrigation projects that we've worked with, pretty poor delivery service, low reliability in supply, poor equity of distribution, where you are along the laterals and along the system, and little or no flexibility. And those things have to be overcome before we can even start to talk about on-farm modernization. The irrigation project modernization is improved infrastructure and improved operations. It is not canal lining, and really that's a waste of money. There's more things that we have to invest in infrastructure and operations, and canal lining is lower on that list. Computer automation alone is not modernization. It's a full strategic plan that looks at improving the water delivery service throughout the project and requires a number of infrastructure improvements and operation improvements. In general, the governments do not do good at operations, these projects. In the U.S., the government, federal government, state government only play a regulatory role. They do not do any operations. Farmers have full responsibility for operation and maintenance. So what happens if the project doesn't go to modernization? Farmers switch to groundwater, or they put in reservoirs. Not much else they can do to get that delivery service. And we know that if you go to groundwater, you tend to have overdraft. You saw the GRACE images before. That's water that's being pumped out. It's not being replenished. Reservoirs are an option if you have the land to take out of production. And typically, larger farmers have an advantage. That advantage is that they're willing to take more risks. They are willing to, or they have the ability to take land out of production for reservoirs, the ability to take larger flow rates and distribute them to their fields to increase their flexibility. So oftentimes we'll see pilot projects on larger farms and we see the success. It's often difficult to scale these down to smaller farmers, typically with the government in charge of the irrigation projects and operations. So even in the U.S., we still have some issues. There are a few projects where the government does run those irrigation districts. We call them districts here in the U.S. Typically for political reasons, long story, but those generally have major issues. And by far, most of the irrigation districts and projects have eliminated all government operation, and the farmers control the management, hiring, and firing of irrigation project personnel. It has to be done that way. Basic economics to improve the water delivery service. This has been known for decades, and I'm sure you've all heard it many times. Still, water user associations internationally are weak, typically, and have little to no power, and which means that modernization, I say will not, but may not be successful, at least the full-blown modernization. So instead of continuing to preach the same things, we at ITRC believe in solutions. So we have some other options. And the last thing I'm going to talk about are maybe an alternative. So if the government's going to want to keep control, then is there a way that we can change the way the water's distributed and change the infrastructure so that we can eliminate or reduce the interaction between the farmers and the government and between farmers and farmers. We won't be able to get full modernization. Irrigation scheduling is still not going to work, but it may improve the delivery of water to the individual plants, improving crop production, and generally making water use efficiency higher. This is an example of something that we recommended in India. They wanted to look into drip irrigation, very low water delivery service. So instead of forcing the issue, the recommendation was to pipeline a delivery. Each of the blue dots is a different grower. The black lines are manifolds that supply hoses. We designed the manifolds and the tape that would be laid out. And so all the irrigation project has to do is provide water to this point. And from this point on, the farmers will rotate their supply and irrigate when they need to. With single speed pump filter stations, and this group of farmers will maintain the pump filters and their individual lines. So we still have fairly inflexible deliveries to this point, but as long as water's there and available, these farmers don't have to interact with the irrigation project. And this is just another design, a similar one, just larger, so each is 3 times the number of farmers that we supply. So these are the types of things that consider when we see things that there's a problem, the solution that we want isn't going to happen, so we have to change the way we view things and come up with better solutions. So just to summarize, on-farm modernization is critical to increase productivity in water scarce environments, without a doubt. The only way you're going to increase your crop production is to improve your on-farm irrigation. And that goes, and I'd say agronomy as well, fertilizing and other economic aspects. Devil's in the details. Water supply service is critical, but also thinking about pumps and power and costs. You're going from surface irrigation to sprinklers or drip. You have to and pressurize that water. So you now have a power cost, and who's going to be responsible for the costs? You have people that can fix things? Do you have parts available? And then back to the irrigation supply, is the government willing to give up control of the irrigation project? If not, are there alternatives that can be implemented to get back to some level of on-farm modernization? And I think we're going to take questions later. So thank you very much.
Thank you so much, Daniel.